Hi folks, we're going to take a look at the solution to number 19 on page 21. So here they're asking us to find the slope of the tangent of this function at the point 510. So notice here they give you the y value instead of just indicating the particular x value, or in this case here p value. So step one, there's not really much to think about here because we have a definition for the slope of the tangent now, and we just apply it. So it's the limit as h approach of 0 of d at, our a value now is 5, so d at 5 plus h minus d at 5 over h. Okay, so now here we just have to input all this into our specific function. So limit as h approaches 0. So here we have 20 over the square root of 5 plus h minus 1. Okay, minus, now d at 5 is already given to us. We know that that's 10 all over h. Okay, now we have an expression here and we want to know what happens to this expression as h approaches 0. Can't really make any determination here because the denominator itself is approaching 0, which causes a problem, but we see that if we input h equals 0, we get 20 over square root of 4, which is 2, 10, minus 10 is 0, so since the numerator is also approaching 0, we have a chance that this limit will exist. Okay, so what we have to do is do some kind of algebra to hopefully come up with a factor of h in the numerator. So here I would say the first step, not much choice in what we do. We'll subtract these two expressions. So limit as h approaches 0. So here we've got 20, since we already have that denominator there, minus 10 times. Now I'll just simplify this. 5 minus 1 is 4. So 10 times the square root of 4 plus h. Okay, all over our denominator of, I guess, 4 plus h. Okay, and of course we still have the h there. Okay, now I'm going to rewrite this to make it a little simpler. So this denominator can be joined with the h in that denominator. Okay, so we have 20 minus 10 times square root of 4 plus h all over h times square root of 4 plus h. Okay, now we still can't really easily determine that factor of h we're looking for in the numerator, but we have something that should be a little more familiar. Is we have an expression in the numerator that's two terms, okay, and one of them here has a square root. So the trick we learned for working with that type of scenario is to multiply by the conjugate. So I'm going to multiply the numerator by 20 plus 10 times square root of 4 plus h, and of course I'm going to have to multiply the denominator by the same expression in order to keep these two lines the same. Okay, and so in the numerator that just creates my difference of squares, so the middle terms will just cancel out, so I'm just left with 20 times 20, which is 400, minus this expression squared, so 10 times 10 is 100, and then this square root of 4 plus h times square root of 4 plus h is just 4 plus h. And of course, make sure you get all that in brackets. And the denominator, I'm not going to be multiplying anything out because I want to keep this factor of h separate. Okay, so now let's see if we can simplify the numerator, and hopefully you're seeing that some nice stuff is going to happen here because we have 400 minus 100 times 4 is 400, and then of course minus 100 times h, so minus 100h, okay, over h times square root of 4 plus h times 20 plus 10 square root of 4 plus h. Okay, and here we go, these 400s cancel out, and now in the numerator I'm just left with an expression that has a factor of h in it, so now this h reduces with that h there. Okay, so in the end, what I'm left with is just negative 100 in the numerator, and the denominator square root of 4 plus h times 20 plus 10 times square root of 4 plus h. Okay, and now I can actually decipher what this expression is going to approach as h approaches 0, because I don't have anything that's going to create a 0 in the denominator anymore. Okay, So at this point here, I'm not going to be writing limit as h approaches 0 because I'm actually analyzing what happens to this expression as h approaches 0. The numerator is just a constant, so it's not affected by the change in h, so that just remains negative 100. And the denominator here, I look at this expression 4 plus h. Well, as h approaches 0, this is just going to approach 4. So I just have square root of 4. Again, the 20 is unchanged by h approaching 0. The 10 here is unchanged by h approaching 0. But this expression, 4 plus h, again, is just approaching 4 as h approaches 0. And so now I can figure out my slope of the tangent. So negative 100 over 2 times 20 plus 10 times 2 is another 20. Oops, sorry, there we go. So we've got negative 100 over 40 times 2 is 80. And if we simplify that, well, let's divide numerator and denominator by 20. So I've got negative 5 over 4. And there's my final answer. Okay. So taking a look at this, question here, certainly, you start to appreciate having developed good algebra skills, okay? Because while we can understand the big idea of how to find the slope of the tangent, we just see how reliant we are on our basic simple algebra skills of just expanding and working with square roots and simplifying expressions. Okay, so let's just do a quick recap. Number one, they told us what we wanted, slope of the tangent at this point. So right away, I just apply my definition for the slope of a tangent. Okay, from there, I input all my expressions, and it's just a matter of very careful algebra to get through all these steps without an error. Okay, and of course recalling that multiplying this two-term expression that has a square root by the conjugate is a very useful trick to use. Okay, and again, maybe the last thing I'll say is you can only remove this expression limit as h approaches 0 when you're actually determining how that expression or what it's going to be equal to as h approaches 0. Up until this point here, we weren't able to do that because of that h in the denominator. Okay, that's it for this one.